Hello. I thought I would do a quick PowerPoint, actually a quick presentation of the PowerPoint provided by the publisher of the important components that you need to be concerned with the chapter. This is a pretty important chapter because it talks about hardware, and if you don't understand hardware, you really are not going to understand how all of this fits together. So let's begin. Our objectives. We're going to understand the terms, very important to understand the terms. The structure, how does it all fit together? Processor, the peripherals. Discuss the main internal systems, the CPU, the RAM, the ROM, and explain why a computer has different types of memory and storage. Now, you should know some of this already, but this should hopefully put it together. Okay, the four basic operations. What do? We receive input, we process, we produce some output, and we store information. Okay, so let's do an example. We go onto the website and we go to Amazon and we shop and we want to buy toothpaste. So the first thing is the computer system, we put input, we identify, we order, we do something, we input information, what we want, into the computer system. The computer system at Amazon takes that information. It does something with it. It probably validates if you're a new customer. It validates if the toothpaste is in. It validates who the shippers are and how long it will take to ship. It validates your credit card information. Then, after it does all this validation, and it takes you through these steps, what does it do? It produces an output. You receive an email saying, hey, you just bought toothpaste. The shipper receives an order saying, hey, this guy just bought toothpaste. The inventory systems are updated. Amazon updates the credit cards. All of these things, the financial systems are updated. And what happens at the end? All of this information is stored. Your client information, your customer information is stored. Your credit card is debited. That information is stored at your bank. All of this information is stored. So you can see that one transaction really impacted many different things. So let's just talk about our little computer here. We have, what do we have? We have our input device, keyboard as usual. If you look at accessibility, we can actually use eyeballs to be able to move data on the computer. Believe it or not, eyeballs. Sticks, voice, these are just different methods, different input devices. Output devices, what are those things? Well, printer is the most obvious, but there's other output devices. Scanners is an example. Microprocessors, what is that? The CPU, that's the guts, that's the big processing unit in the computer. It's the most important part of your whole computer is your CPU. It's how many instructions per megahertz your computer can process. Instructions. We're going to get to instructions, but instructions are simple. They're 1, 0, on, off electrical impulses. Memory and storage, we have many different types. So we have, within the computer, we have something called ROM and RAM. ROM is something that is actually coded in the firmware of the computer. So there's some demographic information that's imprinted into the computer that is always there. It can't change. RAM, however, is information in working storage. So just like our brain, working storage, stuff that we keep there, but when we go to bed, it gets filed someplace else. Working storage, the moment you turn off the computer, that goes away. And peripherals. Peripherals, the printer we talked about, peripherals would be a scanner, for example. My webcam is a peripheral. A speaker I might have is a peripheral. So there's lots of different peripherals that you might have. Information is stored in something called a bit. A bit is nothing more than an on and off electrical impulse, and it's noted by a 0 or a 1, 0 and a 1. So if you look at this particular example here that we're looking at, it's in collections of 8, so that's an important thing to know. We actually do all of this manipulation in collections of 8 in the base of 2. Remember the base of 2 when you were in school? So, the first one is 1, then next of base 2 is 2 to the second, 2 to the first is 2, then 4, 8. So 2 to the third is 8. So if you were to do the number 5, for example, 5 would be 2 to the fourth. So there would be a position right here in this configuration here. And there would be one here, a 4 and a 1. That equals 5. So, here we go. The 4s, because there's nothing in the 2s, because we have a 4 and a 1, 5. All right. So anyhow, ones and zeros. Luckily, we don't have to code in that, so be happy. But if you were an electrical engineer or a firmware engineer, you would be coding in ones and zeros. All right, so here's all these different letters if you really get into it. Things changed. Computers made a huge leap when we could go to ASCII. And ASCII is when we were able to take these 8 unique binary codes and convert them into alphabetical characters. So it was really a huge thing when we were able to then convert it into like a Chinese keyboard, because think about how many letters there are in the Japanese or the Chinese Mandarin or Cantonese language. Okay, so the world's languages, we're not going to go into that, but just think about that. Think about your native language, because we have a lot of native people that are non-English native speakers, and how many letters are in your language. Okay, so a byte is 8 bits. A kilobyte is 1,000. A megabyte is 1,000,000. A gigabyte is a gigabyte, terabyte. You can see 1,000, million, billion, trillion, quadrillion. Petrobyte, a quadrillion. It's even hard to imagine. But that's what these mean. So if you say I have a gigabyte, that means you have storage for 1 billion bytes of ones or zeros. 1 billion bytes. A terabyte, 1 trillion bytes. A petabyte, 1 quadrillion. That's a lot of data. All right. Now you have to remember though, if you store a lot of pictures, pictures are all pixels. Pixels take up a lot of space. So, it's all relative as you start to think about, oh, these are huge numbers, I'll never meet them. But it depends upon the media that you're storing. Okay, so like I said, digital computer, on and off switches. Okay. Input is what instruction the user puts into the computer. Output is what the computer returns to them. This is pretty simple. CPU, often called the processor. And this is what it does. It transforms inputs into outputs. Think about that Amazon example. It interprets your customer information, looks to validate to see if you are really a customer or if you need to add. It could perform arithmetic equations. So when you buy something, it puts the shipping and the tax, and maybe you're Amazon Prime, so you don't have to do shipping. And then it communicates with other parts of the computer, i.e. the printer, i.e. it might be a scanner, it might be a fax, but other parts of the computer through the memory. It might be storage. That's probably the biggest place. The modern microprocessor. It is complex electric circuits. So we had a question last week on the quiz about the difference between, the transistors and going to the circuits. And the real reason was size. Now it's because size and capacity to be very efficient and very fast. But originally was size. This little board here with all of these circuits and all of these different types of devices is called, device being only circuits, by the way, and chips, is called the motherboard. Motherboard, you must know that. When you're choosing a computer, what are you looking at? Well, I looked at size, to be honest with you. But you really want to look at the capacity, how fast can it interpret instructions. And that's very important. For example, if you're doing movies and things, you want something that's going to have a lot of RAM to be able to really keep it in memory, especially if you're streaming. And performance. I did look for performance because I do SPSS calculations, and calculations require a lot of space. All right. Not all software is compatible with every CPU. We already know that. When we go from one version of a software to another, they're supposed to be backwards compatible, but sometimes they're not. For example, you can't take things from Windows XP and try to run them into Windows 10. It does not work. It's not supported. So you need to really find out if something is backwards compatible, meaning did it go back generations? AMD processors are compatible with Intel, which is great. Programs written for Linux can't run on Windows. So, there's all these different types. And Mac has got a whole different operating system with Safari. And I think Yosemite now. I should look to see what I have. All right, performance, some are faster. The speed of the internal clock is measured in gigahertz. The architecture of the processor, that is the design of the CPU. Typically, the number of bits can process. It's typically the number of bits that one can process at one time. And they're calling it word size. So a bit is anywhere between 32 to 64 bits, depending upon, the configuration of your machine. Heat increases the clock speed. So, one of the things is computers now are solid state, meaning that they don't have as many movable parts, so they don't generate as much heat, so they can do more processing. But in the old days, you used to have a little fan actually running in your computer. And if the fan burned out, then you would have data just kind of disappear. I had that problem. All right, moving on, single chips, multi-chips, you can look at this more later. Look at that more later. Multi-cluster, parallel processing, very important. This has been something that has been used in high-end servers and workstations for some time. When I was IT director for a hospital, we did a lot of parallel processing because we were taking in large volumes of information, and we would want to be able to process as much as we can. Because what happens is sometimes when a piece of instruction comes into memory, it might have to go out to the server to get some kind of validation. So while it is waiting for the server to respond, it can be processing something else. So that the server, the CPU, is never idle. It's always taking an instruction and doing something with it. Okay, by the way, did you notice we're in my kitchen in case the camera is working right? Here's the CPU. And this is a very interesting diagram I just want to point out to you. So we looked at that CPU before. This is the bus, the group of wires. Here is the RAM. RAM, that's the memory in the computer, that when you shut that computer down, whatever was in there goes away. And, that's the working storage memory is what I call it. The bus interface, here's the arithmetic logic unit, the control unit. And if you think about a computer, they try to actually to simulate the brain because we have a part of our brain that is known for more quantitative type of things, logic. We have another part that's emotional. I don't think the computer really has that emotional part. So RAM, most common type of primary storage, temporary. Memory locations have unique addresses. So every place in memory, in both RAM and in long-term storage, has a location. So it's pretty interesting. It's actually, data is stored, and in this, there's like a table, and all systems are a little different, but it keeps track of the location, and the location then takes you to the actual data. Okay, so the read-only memory, ROM, it's information that is stored on the chip. I told you about that. The firmware. Complementary metal oxide semiconductors. Special low energy type of RAM. These are very common now in our solid state computers. Flash memory can be written and erased very easily. So it could be a flash drive memory. Solid state has some flash memory too. All right, so this whole thing about memory, you can look at this a little more later, but the executing of instructions occur in RAM. If they don't occur someplace else, they occur within RAM. When you turn on the computer, the CPU automatically begins operating, and it does that because there's instructions that have been stored in the firmware that know how to boot it up. Now, if your firmware gets damaged, then you're in bad shape because then it's not able to even boot up the computer. That's when usually they tell you, got to get a new one. The executing instructions help the computer start up. They tell them how to load the RAM. Once the instructions for the operating system are loaded into RAM, the CPU is able to execute them. Everything happens in RAM. So the bigger your RAM, the more things you can do. So you start to understand this. Information travels along the buses. So you saw those buses, and they're just bridges between the processors and the RAM. And expansion slots that give us more RAM. So you can have, I don't know about you, but you could buy your computer and it might come with 64 gigs of RAM, and then you might want to increase it. So you have to get another chip, and you added in another extension slot. So these buses then allow us to connect one chip to the next chip. Ports, USB ports, we all look for ports. They're, for your external speaker, charging your phone, charging my recorder, there's never enough slots. Anyhow, they are, for your flash drive, all of those things. And peripherals, we talked about those. They could be things like my camera, my speaker, my printer. Green computing, it's the whole idea that when compared to other industries, it's relatively easy and clean. you need a clean room just to create the motherboard and all the chips. In the Silicon Valley, they have to have what they call clean rooms. All right. So that's the summary of Chapter 2. I want you to go through it. You need to know these terms because they're very important. This week, follow what is in the module. And if you have any questions, send me an email. Thanks, and I hope you've enjoyed this quick abbreviated lecture. Bye-bye. No, there's a lot of summary items. There we go.